Welcome to another thrilling episode of Space Alert, your ultimate space station on YouTube. Today, we're setting our sights on a journey that stretches to the very bounds of the cosmos. Ever wondered what's beyond the farthest stars? What secrets lurk at the edge of the universe? Well, strap in and grab your telescopes, because we're about to explore the great unknown and unravel the mysteries at the cosmic frontier. Let's get ready to push the limits of space and perhaps, our imaginations. Are you ready? Let's dive into the cosmic ocean. Welcome aboard, fellow cosmic travelers. Today, we're starting our interstellar journey by exploring the very concept of the observable universe. So, what exactly is it? Well, imagine a cosmic bubble, and you are at the very center. This bubble represents all the parts of the universe that we can observe from Earth, not because we have limitations in technology, but because of the age of the universe itself. You see, the universe is about 13.8 billion years old. Light from the farthest edges of this observable universe has traveled for 13.8 billion years to reach us. In essence, when we look into the night sky, we're not just stargazing, we're time traveling. We see stars and galaxies not as they are now, but as they were millions or even billions of years ago, which is pretty mind-blowing. But here's the twist, the universe is expanding. Due to this expansion, light from distant galaxies is stretched to longer, redder wavelengths, a phenomenon known as redshift. This redshift helps astronomers determine the distance of celestial objects from us, but it also means that the universe is much larger than the observable part. In fact, what we can see is just a tiny fraction of the full universe. The boundary of the observable universe is known as the cosmic light horizon. Beyond this horizon lies the unobservable universe. It's like standing on the shore of an ocean, looking out at the horizon. You know there's more beyond it, but you can't see it from where you're standing. Our cosmic horizon is similar. It limits our view not by distance, but by time. The farther away something is, the longer it takes for its light to reach us. And if the universe is 13.8 billion years old, that means there's a lot out there whose light hasn't had enough time to reach Earth yet. Now, let's sprinkle some cosmic wonder into this scientific mix. Did you know that by studying the light from the cosmic microwave background radiation A, which is the afterglow of the Big Bang, astronomers can decode many secrets of the universe's infancy? It's like having a baby photo of the universe itself, showing us the earliest moments after its birth. So, as we sail through this vast cosmic sea, remember, each star, each galaxy tells a story, and these stories are ancient histories written in light, waiting for us to uncover them. What will we find as we reach further and peer deeper into this cosmic ocean? Stick around as we dive into the mysteries of dark matter, dark energy, and what they tell us about the fate of our universe in the next segment. This approach to explaining the observable universe combines scientific facts with vivid imagery and metaphors to make the concept both understandable and captivating for viewers. Alright, space fans, let's dive into the latest discoveries that challenge the very fabric of our understanding. Imagine the universe as a giant cosmic ocean, and we've only explored the surface. But with the tools we have today, we're starting to dive deeper than ever before. The Hubble Frontier Fields Program, Hubble, our trusty space telescope, has been at the forefront of cosmic exploration since 1990. In one of its most ambitious projects, the Frontier Fields Program, Hubble peered into 6 massive galaxy clusters. These clusters act like natural telescopes, their immense gravity magnifying the light from more distant objects behind them. This has allowed us to glimpse some of the earliest galaxies, giving us a peek into the cosmic dawn, nearly 13.8 billion years ago. These images are not just beautiful, they're like cosmic postcards from the edge of the observable universe. The role of dark matter and dark energy. Now, let's talk about the universe's most mysterious players, dark matter and dark energy. These aren't just elements of a sci-fi plot, they are real and make up about 95% of the total mass energy content of the universe. Dark matter holds galaxies together, and dark energy, it's the force behind the universe's accelerated expansion. By studying how galaxies are moving and how their light bends, astronomers are uncovering the properties of these invisible forces. Think of them as the hidden architects of the cosmos, are shaping the universe, yet remaining unseen. The James Webb Space Telescope, JWST, enter the next big name in space exploration, the James Webb Space Telescope. Launched in December 2021, JWST is designed to look further back in time than Hubble ever could. Equipped with a suite of infrared cameras and spectrometers, JWST is our new window into the infancy of the universe. It will study every phase of cosmic history, from the first glows after the Big Bang to the formation of solar systems capable of supporting life on planets like Earth. And yes, it will probe the edges of our observable universe, potentially revealing what lies beyond the cosmic horizon. Implications of cosmic microwave background, CMB. Radiation. Lastly, let's not forget the cosmic microwave background, or CMB. This relic radiation provides a snapshot of the universe just 380,000 years after the Big Bang, long before stars and galaxies formed. Recent measurements of the CMB by missions like the Planck satellite have given us a detailed map of the early universe. Variations in the CMB tell us about the distribution of matter and energy when the universe was young, offering clues about how everything we see around us eventually formed. So, whether it's using galaxy clusters as cosmic magnifying glasses, decoding the mysteries of dark matter and dark energy, or peering back to the universe's infancy with JWST, every piece of the puzzle helps us understand the grander cosmos. It's like being cosmic detectives, where each clue unravels part of the universe's greatest mysteries. Stay tuned as we continue to explore and possibly redefine the boundaries of what we know. Who knows what we might discover next, or perhaps the edges of our observable universe are just the beginning. Now that we've touched on what the observable universe is and what we can see with our current technology, let's dive into the exciting and sometimes mind-bending theories about what might lie beyond. The universe is not just a space saga, it's a science thriller. One of the most exhilarating theories in modern cosmology is the concept of the multiverse. Imagine that our universe, with all its galaxies and stars, might just be one bubble in a cosmic foam of countless other universes, each with its own laws of physics. It's like having infinite episodes of your favorite sci-fi show, and each one has a different plot twist. Michio Kaku, a renowned theoretical physicist, gives a vivid analogy. Think of a bubble bath. The multiverse is like a foam of bubble universes, and we are just living inside one of them. Kaku suggests that these other universes could be vastly different from our own, or surprisingly similar. We won't know until we can find a way to peek across. Another mind-stretching theory is cosmic inflation, which proposes that the universe underwent an exponential expansion in the first fractions of a second after the Big Bang. This wasn't just any growth spurt, it was the universe on a turbocharged sprint, faster than the speed of light. Cosmic inflation explains why the universe appears flat and uniform in all directions. Alan Guth, the originator of the inflationary theory, describes it as the ultimate free lunch. He says, inflation is such a powerful expansion that it can take a tiny, subatomic space and stretch it larger than the observable universe in less than a blink of an eye. It's like upgrading from a tiny apartment in the city to a sprawling estate that spans galaxies, almost instantly. Then there's the string theory landscape. This theoretical framework suggests a universe composed of tiny, vibrating strings. These aren't ordinary strings, think of them as the fundamental notes that compose the symphony of the cosmos. The different ways these strings can vibrate represent different fundamental particles. And just as different musical compositions can exist, there could be a vast number of possible universes, each with its own set of string vibrations. Brian Greene, a string theorist, offers this musical analogy. Imagine the universe as a cosmic symphony, played by strings whose vibrations obey the laws of physics as we understand them. Change the tune, and the laws change along with it. According to Greene, our universe might just be one tune in a grand cosmic playlist. These theories take us to the edge of human understanding and imagination. They're not just about looking through telescopes, they're about looking through the kaleidoscope of possible realities. What lies at the edge of the universe could very well depend on which theoretical lens we look through. Alright, now that we've soared through the cosmos and peeked at the edge of the observable universe, let's talk about why this isn't just cool, but also incredibly significant. You see, exploring these cosmic boundaries isn't just about satisfying our cosmic curiosity, it's about unraveling the very fabric of reality itself. First off, let's get a bit philosophical. What does it mean for us, tiny humans on a small planet, to even ponder the edges of the entire universe? It's kind of like an ant trying to understand the internet. It's mind-boggling. Yet, here we are, pushing the limits of our understanding. Each discovery in space acts like a mirror, reflecting not just the stars, but also shining light on the depths of human ingenuity and spirit. Imagine for a moment if the universe is indeed infinite, or if there are multiple universes as some theories suggest. What does that say about the concept of infinity itself? Or about the very nature of existence? These aren't just idle thoughts, they shape our understanding of everything from physics to philosophy, influencing how we perceive both the cosmos and our personal lives. Michio Kaku once mused, "To understand the universe, you must know the language in which it's written, the language of mathematics. But perhaps, we also need the language of philosophy to grasp its true meaning." Now, swinging from the philosophical to the practical, studying these cosmic frontiers has some down-to-earth benefits too. Every time we develop new technologies to peer deeper into space, those same technologies often find uses right here at home. For example, camera sensors initially developed for space telescopes are now used in medical imaging, helping to save lives. Moreover, by understanding the universe's expansion and the forces at play, we can better navigate our future in space. This isn't just about the next moon landing or Mars mission, it's about long-term survival as a species. As we learn more about potential threats from asteroids, solar flares, or even distant cosmic events, we can prepare better defenses to protect our planet and future generations. Linking the philosophical with the practical, consider this: the mere act of exploring the universe teaches us about resilience, creativity, and the power of collective human effort. It's a reminder that we are part of a bigger picture, a vast, intricate tapestry of matter and energy, stretching through time and space. As we reach outward to the stars, we also reach inward, questioning our beliefs, our values, and our goals. As we reach the edge of the observable universe in our discussion, we find that the final frontier of space may be just as limitless as our curiosity. Each new telescope and every groundbreaking theory takes us one step further into the unknown, challenging our understanding and stretching the fabric of our cosmos. What's beyond the observable universe remains one of the great mysteries, so perhaps it's more universes, new dimensions, or something entirely unimaginable. So, what do you think lies out there in the great beyond? Share your ideas in the comments, and let's keep exploring together. Remember to subscribe for more cosmic adventures with Space Alert. Until next time, keep your eyes on the stars and your mind open to the infinite possibilities.